6.3 Matrix Algebra. In this section, we are going to learn how to add and subtract matrices, multiply a matrix by a constant, multiply matrices, solve the applications using matrices. Matrix is an M multiplied by N array of the M numbers arranged. M represents the rows, N is the column. We say that the matrix is of size M by N. For example, I have the matrix A. With the matrix, we use a big bracket to run the element of the matrices. For example, I have 2, 1, 3, 1, 0, -1. This matrix has the dimension, or you call size, as the size is defined by row multiplied with a column. So this matrix A has a 2 rows. So we put a row in the front, the number of the row in the front, multiply with the column, the number of the column of the matrix. So this matrix A has a size is 2 by 3. We do one more practice. Matrix B has 1, 2, 3. So this matrix has 3 rows, 1 column. So we wrote the size of the matrix A is a 3 by 1. And we can say any of the following notation to denote the M by N of matrix A. So it has the M rows, it has the N column. So you will have the M multiplied by N. Equality of matrices. If matrix A has the size is I multiplied by J, matrix B has the same size I multiplied by J, so they have the same dimension or they have the same size, then your matrix A is equal matrix B. Now this one, it just tells us if I have matrix A is 1, 2, 3, 4, and the matrix B has X, Y, Z, 4. If these two matrices, they are equal and they have the same dimension, 2 by 2, matrix A has 2 by 2. Let me write down on the side. Matrix B has 2 by 2 as well. So in that case, the corresponding position, they are equivalent. So from here, we can define X equal 1, Y equal 2, Z equal 3, and the 4 equal 4. So when two matrices has the same dimension, has the same corresponding position, in that case, your matrix A is equal matrix B. How do we add and subtract matrices? Sum of two matrices, we just use the corresponding position or corresponding entries of the matrix A and B to sum them together. We take a look at example here. I have two matrices. Matrices want to combine together. Now we need to define the dimension of the matrix. When you add or subtract two matrices, they need to have the same size. Otherwise, they cannot combine or subtract. So the first matrix, we have 2 by 3. Second matrix, it has 2 by 3 as well. So this information indicate, yes, they can combine together. Now the way we combine two matrices, we go with the same corresponding position to sum them together. So we use the 2 plus 1 equal to the 3. We use the 1 plus with negative 1 equal to 0. 3 plus 2 equal to 5. Now we move on to row 2. The first entry on the row 2 is 1. The first entry on the row 2 of second matrix is negative 1. So 1 plus negative 1 equal to a 0. Negative 1 plus 1 equal to a 0. 0 plus 5, it has 5. The dimension of your result when combine two matrices, it will keep the same dimension. The size will remain the same. So you still get a 2 by 3 matrix by the end. So same way, when you subtract two matrices, you use the same procedure. Recognize the size of two matrices, whether they have the same dimension. When you subtract two matrices, we do this one with a subtraction. 2, 1, 3, 1, negative 1, 0, minus 1, negative 1, 2, negative 1, 1, 5. So since we already defined both of the matrices have the same dimension, so now we just go ahead to subtract from the first matrix to the second matrix. Now 2 minus 1, we get a 1. 1 minus negative 1, it turns to a positive 2 because you have double negative sign here. So it turns to a positive 2. 3 minus 2, we get a 1. Now we move on to the row 2. 1 minus negative 1, it turns to a positive 2. Negative 1 minus 1, it turns to a negative 2. 0 minus 5, you get a negative 5. Again, the result after you subtract two matrices, they will have the same dimension, 2 by 3. Now we move on to zero matrix or additive identity matrix. This information just tells us a matrix itself to combine with a zero matrix. We can swap the order. We put a zero matrix in the front to add the matrix A. The result is still go back to the matrix itself. For example, matrix A, I give a 2 by 2. So 1, 2, 3, 4. This is a 2 by 2. Now a zero matrix, in order to combine with the matrix A, it must have the same dimension as well, which is 2 by 2. Otherwise, these two matrices cannot combine. Now, a 2 by 2 zero matrix will be 0, 0, 0, 0. Zero matrix of a 1 by 1, you will have just a single number 0 inside of the matrix. When you have a 2 by 3, zero matrix of 2 by 3, you will have 0, 0, 0, 0, 0, 0. That means the size of the zero matrix you can manipulate, but the element inside of the zero matrices, they are always has the same element, which is the number 0. We call it zero matrix. So any matrix combined with a zero matrix, or the zero matrix combined with any matrices, it will go back to the matrix itself. We call this as additive identity. Another one is additive inverse of a matrix. That means when you combine the matrix A and the opposite matrix, the negative matrix of the matrix A, or when you swap the order, negative matrix A to combine with the positive matrix A, you will get a zero matrix. For example, the matrix A, I did the matrix A is 1, 2, 3, 4. It's a 2 by 2. The negative matrix A, I will have, alright, let me rewrite this one. Okay. We put a matrix B. So the matrix A is 2 by 2. Now when I combine with the negative matrix A, so that means A matrix A plus negative matrix A. So the matrix A was 1, 2, 3, 4 plus the negative matrix A. I just multiply negative 1 into each element of the matrix A. So I will get a negative 1, negative 2, negative 3, negative 4. Now we combine, we add these two matrices together. So 1 plus negative 1, you get a 0. 2 plus negative 2, you get a 0. And the remaining 2, they are the same. So when the matrix plus the opposite of the matrix, we call additive inverse. You are doing processing the inverse of the addition, right? The inverse of the addition, that is the subtraction. So when you have A plus negative A of the matrices, you will get a zero matrix. Differences of two matrices. If A and B, they have the same dimension, their differences A minus B is the sum of the matrix A and the additive inverse of matrix B. That means you just subtract two matrices. We move on to multiply a matrix by a constant. That means outside of the matrix, you multiply a single number. And we call a number is a scalar. So that means when I use a number like say 2 multiply with a matrix A, in that case, like say the matrix A I have 1, 2, 3, 4, and then you just simply to distribute this scalar number into each element of the matrix A. So it will turn to 2, 4, 6, and 8. And that's it. Now we do this example. One matrix I have 5y, 15z is a 2 by 2. The right hand side matrix I have x3, 3y. However, outside has a scalar number there. Now you need to solve for y and z. So we do use the same concept when we process the algebra. Phi is a scalar. I'm going to multiply phi into inside of each element from your right hand side matrix. Now the left hand side, we keep it the same. Now the right hand side matrix, I will have phi x, 15, 15 by y. So in order to determine your y or x, you have to make sure on the both sides of your equation, you only have the single matrix here. Single matrix, right? Single matrix. That means there's no scalar number outside.